this video we will continue about the constant temperature cycle. Previous video we see about constant volume cycle and constant pressure cycle. So in this case we consider state 1 and 2. Here is the temperature value T1 is equal to T2. This is constant process. So for this process we draw about pressure and volume diagram. Pressure is a unit as Newton per meter square and volume is in a meter cube. So here is the two type of pressure values here. Here is in a pressure value 1 and here is in a volume value 1. So this is P1 comma V1 and this is P2 comma V2. The graph it will be in a, some type of curve value indicated as process 1 to 2. So this is the constant pressure and temperature value process. Here is in a PVT relationship for this constant temperature cycle is PV is equal constant. Therefore, P1 V1 is equal P2 V2. Similarly, we like that it is an adiabatic process. Adiabatic process. In this adiabatic process, there is a heat flow will be a zero condition, and gamma it is the name of adiabatic index, it is a 1.4, and the final closed cycle is polytropic process. Polytropic process. Here is the n is in a value of 1.5 is in a polytropic index. So these three processes are under the category of constant closed cycle properties and parameter system, and it will be stated or it will be applied to the properties to find about the heat transfer and work done and change in internal energy, change in enthalpy and change in entropy also, and also the parameters of pressure, volume and temperature in each stage. So this is the cycle of constant temperature and adiabatic and polytropic process. In these three closed cycle properties are which follow the law of first law of thermodynamics. So the first law of thermodynamics is represent total Q is equal to total work done. So first law of thermodynamics states that the net rate of heat transfer is equivalent to the net rate of work done. In this all closed cycle properties and open cycle properties, it will be under the category of previously we said that about steady flow energy equation. So this thermodynamics concept is basically from or basically to drive or applied to any type of engine or any type of energy conservation from electrical to mechanical type of energy work. So in this finally we have to conclude about this three cycle process and process parameter and pressure volume relationship diagram also. For in case we need to find or we need to draw about temperature volume cycle of this process. This is a TS diagram. S it means entropy and T is in a temperature. So in this TS diagram for constant temperature processes, here is a temperature, it will be a constant area. So here is a temperature, it will be in a constant is 1 and is 2 and S it will be changing. Here is in a S1 and here is to the S2. So this is the T1 S1 and this is T2 S2. This is temperature and entropy diagram for constant temperature process. Similarly, we can try to find out the temperature entropy cycle for adiabatic process and polytropic process also, and it is effective to find the numerical dissipation like numerical formulated value for the above three process calculation in said that about change in enthalpy del H and change in entropy del S and heat transfer del Q and work done of del W. This is the we have to find about using the pressure volume and temperature entropy cycle relation. Thank you.